spewing fire, soaring through the sky, with wings as wide as buildings are tall. These are our human-made dragons.
It can fly from Japan to the continental US without needing to refuel.
Since humans took to the skies, we've dreamt of bigger, faster, longer flights.
The new boom technology transfers fuel so fast that would fill up your car in a second. It's unbelievable.
We've broken the sound barrier and the pull of gravity, and many of our spectacularly designed creations would leave the dragons of folklore in their dust.
These airplanes can perform specialized missions with oversized loads that no other aircraft could perform.
The colossal machines that we've created can outsize our wildest imagination. What they can do is no less than a miracle of engineering. But it's the secret ingredients inside that allow them to perform mind-blowing tasks, and in turn, make our limitless human ambitions come true. What do you do when you need to move something huge across massive distances quickly, where no train or ship can do the job? Meet the C5 Galaxy. Nicknamed the Screaming Giant because of its ground-shaking takeoffs, this beast is the largest plane used by the US military. Its wingspan is about 68 meters, and tip to tip, this giant is about 75 meters long.
The C5 Galaxy is one of those truly awe-inspiring sights. This is a truly behemoth aircraft. It does what almost no other aircraft on Earth can do and move massive amounts of equipment around the world.
Its cargo compartment capacity is about 880 cubic meters and can hold 6 school buses.
Everything about this airplane is colossal. The paint coating alone is up to 1,300 kilograms on this airplane.
With a flying machine of such size and heft, the first thing that had to be considered was merely getting it off the ground. For example, rigid wings would snap under such massive weight. The secret of this bird's success starts with the design of its wings.
You know, when you see it on the ground, the wings are angled down, drooped, sort of thing. But as it's generating lift, the lift force, you'll start seeing the wings are going up. And so the wings can deflect approximately 3 to 4 meters from where they are standing on the ground under gravitational force versus when it's in the air.
Not only can they move, but their placement makes moving cargo in easy.
The Lockheed C5 Galaxy has a high wing design, so the wing is located on top of the fuselage. The reason that that is done is so that the belly of the aircraft, the load floor, is down closer to the ground.
As well as its wing design, to help thrust this hulking machine into the air, Lockheed needed something considerably more powerful and efficient than the turbojet engines of previous cargo planes.
The thrust that they had to get to, they weren't going to get there with turbojet technology. So then they had to go to high bypass turbofan. And really, the C5 Galaxy, the requirement for the C5 Galaxy, created that.
The new engine Lockheed developed was called the TF-39 High Bypass Turbofan. And as the name suggests, its magic is in its fans.
The turbofan is very similar to a jet engine. It includes the whole core, but at the front, we use additional power generated by the turbine to run a fan. And that fan is basically kind of like a propeller with many, many blades that pushes some air around the outside of the engine, bypassing the jet component and giving us extra thrust out the back of the engine.
The C5's powerful engines have gotten even more powerful with decades of upgrades. And the 4 turbofans on the most modern version of the C5 are 2 meters in diameter, with an airflow of almost 1 ton per second. This, in combination with its large fuel tanks, which can hold 150 tons, means it can fly over 8,800 kilometers without refueling.
High bypass turbofan engines are among the most efficient turbines in the world. It can fly from the continental US to Japan without needing to refuel.
And it'll perform specialized missions with oversized loads that no other aircraft in the US Air Force or NATO could perform. The cargo hold of the C5 Galaxy is large enough to carry anything that is required by an armed brigade, including mobile bridges, armored personnel vehicles, trucks, ammunition, food.
With a maximum takeoff weight of over 380 tons, the C5 was a game changer.
You can park 2 battle-ready tanks in the cargo hold and be able to take off.
Its massive cargo compartment measures about 40 meters long by 6 meters wide and 4 meters tall. And to this day, it remains the cargo plane of choice for long-distance military or humanitarian operations. But while loading a plane of this size might be relatively simple, unloading can be time-consuming, and time-consuming can mean dangerous in a war zone, which gave engineers another design problem to solve. How could they make this mammoth cargo hold easier and faster to unload?
The aircraft has very special landing gear that allows it to kneel closer to the ground.
First of all, its landing gear has 28 wheels, which evenly distribute the C5's great weight on the tarmac when touching down. To move even more deftly, its rear landing gear can also be made to caster, allowing the huge craft to have a very small turn radius. Then, once it's parked, its kneeling gear lets the aircraft lower, so the cargo deck can get to truck bed height to facilitate easy unloading and loading.
The access to the cargo bay is made easy by ramps not only at the back of the aircraft, but at the front.
Amazingly, the nose cone, also called its visor, actually swings up to become a massive front door.
The nose cone rotates up out of the way. A ramp is deployed out of the front of the aircraft, so you can literally drive a tank on at the back when you pick it up, close the cargo hold, fly to the other side of the world, land, the aircraft kneels, the nose cone comes up, a ramp deploys out the front, and then you can drive the tank off the front of the aircraft.
Then you can bring a new load on from the back at the same time.
When the C5 is reloaded and takes off again, its special landing gear can rotate 90 degrees before being retracted. One more thing engineers had to consider was that this massive craft is also hugely visible. If the C5 was carrying supplies to a war zone, it would be a very easy target. As it came in for landing, it would only take one person hiding with a ground-to-air missile to destroy it. And what they gave this giant as protection is nothing short of spectacular. The C5 Galaxy uses flares in its state-of-the-art anti-missile defense, which combines a warning system with a countermeasure dispensing system. When a threat is perceived, flares are dispensed, which act as decoys. Since missiles seek infrared heat targets to lock onto, the flares make themselves the target, distracting the missile away from the aircraft's engine and causing it to lock onto the flares instead. The C5's dazzling way of defending itself is the icing on the cake with its design, taking it to a whole new level of cargo plane and one that has reigned the skies for more than 50 years. In addition, since its first construction, the C5 has been continually improved upon. From the avionics to upgrades in navigation and maintenance diagnostics, to more efficient and faster engines, this monster of the skies is now known as the C5M Super Galaxy.
This plane is amazing. It has the ability to fly really long distances and refuel as needed. So that allows the machine to continue on. The only real limiting factor is the fatigue of the crew.
The brilliant and massive screaming giant will likely reign for many more decades to come. Ever since humans started to fly, we've looked for ways to stay in the air longer. From the beginning, we imagined, if only we didn't have to land for refueling, our planes could be so much better for transport in emergency and in battle. The earliest attempts at refueling aircrafts mid-flight began in the 1920s, and it would be hard to imagine something more high risk.
You've got to be fairly close together to allow this to happen. And you're moving at what speeds? 500 kilometers an hour plus, not more. And you've got to maintain that speed. And so you're threading a needle. in the air, which is unpredictable, and there's just so much stress. So back in the old days, what they did is they actually lowered their altitude to depressurize so that a person could climb outside of the plane and grab this hose and plug it into their plane. You think about this, you're flying. You're trying to transfer a flammable liquid from one flying plane to another flying plane. So you've got this plane that drops in behind this other plane, and the first plane basically dangles a hose that needs to be fairly stable and rigid to prevent any sort of erratic movements. You need to plug that into a coupling, a fitting, a housing of some kind that can seal off to transfer that liquid from one plane to the other. There's a person outside of the plane doing this work with this highly flammable material, static electricity everywhere, at high speeds. The whole scenario is mind-blowing, just mind-blowing that people would do this.
There were a lot of hazards. If the hose broke, it would spray fuel all over the lower airplane, which could easily catch fire and obviously destroy the airplane and kill the crew. There were lots of ways this whole system could go wrong, and sometimes it did.
Thankfully, air-to-air refueling, or AAR, has come a long way in almost 100 years.
In 1945, they came up with the auto-couple refueling nozzle. This was a huge, huge breakthrough. So what this allowed was that once they coupled together, they joined and they stayed together. This would also allow that if there's any movement, it didn't break off. So it allowed the ability to have movement of the aircraft relative to one another. It's a huge breakthrough.
Refueling aircraft are called tankers. And after the Second World War, these tankers grew in importance. Air power came to dominate militaries in warfare, but also as a mode to transport troops and materials. Armies needed planes to stay in the air for vast distances. And they needed their tanker planes to carry bigger and bigger amounts of fuel. One tanker plane has rewritten the rules of the sky, the Airbus A330 MRTT. This massive beast first took flight in 2007 and has by far a higher fuel capacity than any other. Used by the UK's Royal Air Force, amongst others, it's based on Airbus's massive A330 passenger plane. But as MRTT denotes, it's a multi-role tanker transport. It can carry 111 tons of fuel. By comparison, this is a full 11 tons more than the US military's Boeing KC-135 tanker.
The A330 MRTT has a huge range. It can fly over 16,000 kilometers without needing to be refueled.
This aircraft can fly the equivalent distance from Perth, Australia to Denver, Colorado at an average speed of 1,054 kilometers per hour.
But even more amazing than the range provided by the Airbus's fuel capacity is how much of its fuel it can offload to other crafts in refueling missions. A staggering 50 tons worth. Its arrival on the scene marked a 21st century benchmark for new generation tanker transport craft. And where it carries that fuel is part of this Dragon's multi-role design.
The fuel carried in the A330 MRTT is all within its massive wings. The nice thing about this is that it does not use up any space in its main deck or in its lower deck for fuel, so that is left for cargo or payload. When not being operated in a tanker role, the aircraft can carry up to 300 passengers on board. So when you're transferring troops into a safe area sort of thing, almost like a commercial airliner. So that's really good. It could be a tanker, it can transport people, it can transport cargo.
It can change layouts to act as a medvac, with 40 stretchers and 20 seats for medical staff.
If that isn't enough, the MRTT can simultaneously take 4 aircraft with it, perform refueling operations, so they can actually transfer together. They can carry up to 50 personnel at the same time in the airplane, carry 12 tons of equipment or spares, and actually fly a non-stop flight with all of those aircraft and equipment from Europe to Afghanistan. That is true multi-role capability.
Today's jets fly at incredible speeds, some approaching 3,000 kilometers per hour. But the design streamlining required for such speed doesn't leave much space for fuel. So, in-flight refueling is vital for extending these crafts' range. And high-speed jets require high-speed refueling. The A330 MRTT has come a long way since the tank of yesterday. It can refuel at over 10,000 meters and at a cruising speed of 555 kilometers an hour. And while it can pull off this task much more safely than its predecessors, it's a nerve-wracking feat to behold. The first way the A330 refuels is by using a probe and drogue method. The tanker is equipped with a hose drum unit, not very different from the design of your garden hose at home. The flexible refueling hose is reeled into or out of the drum when needed.
It is important that the refueling hose be stable during in-flight refueling. And at the end of the hose, there is a drogue, in effect like a chute. Two things that the drogue functions at. One, to stabilize the hose, and two, it gives a large target, an opening for the pilot on the receiving aircraft to insert the receptacle from his airplane into the refueling drogue and hose.
With the hose stabilized in flight, it's up to the receiving plane to complete the task. The receiving plane has a probe, which is a rigid, protruding, retractable arm placed on its nose or fuselage to make the connection.
There is a valve in the probe of the aircraft that will be receiving the fuel. That valve actually connects to the drogue receptacle, and then once those have connected together, that allows the fuel to transfer from the A330 MRTT to the aircraft that is receiving the fuel, be it a fighter, transport aircraft, helicopter.
Amazingly, this flying gas station can also service 2 customers at a time. But even a system as advanced as this is not adequate for some situations. For example, if a fighter is on a dangerous and time-sensitive mission, it might need to refuel even faster. And the way that the A330 is able to accommodate this is perhaps the biggest superpower of all. It's called an ARBS, or Aerial Refueling Boom System. And it can deliver fuel at an almost unfathomable 3.6 tons per minute.
The new boom technology transfers fuel so fast that would fill up your car in a second. It's unbelievable. Imagine just going to the gas tank and being like, boop, done. When I think about the concerns, you're pumping fuel this fast. What if that mechanical connection were to fail? What if that coupling wasn't able to seat properly? You're pumping this massive amount of fuel per second through these lines. A rupture, a leak could be catastrophic.
High technology keeps it safe. This flying boom is a rigid, telescoping tube controlled by a refueling operator on the tanker aircraft, watching a high-definition screen. When the receiving plane gets into formation, the control operator on the MRTT commands the boom with V-shaped fins located on the telescopic beam.
The operator in the aircraft gets a stereoscopic view of the upcoming aircraft to be refueled. Basically, they have a set of goggles that are connected to cameras that makes it look like they're sitting directly outside the aircraft on the boom. This, in combination with a control system, allows them to guide the fuel port directly to the port on the aircraft, make the connection, and transfer fuel while in flight.
The fuel pipe ends in a nozzle with a flexible ball joint, which mates with the receiver's refueling receptacle.
At the end of the fuel hose, there is a flexible ball joint that allows for some movement. That ball joint connects into the receptacle, where it then locks into place via toggles on the receiving side to hold it in place. There's also a valve that won't open in the fuel hose until that connection is all solid and verified. Once that connection is verified, the fuel can begin to flow.
The design is brilliant, but it's about to get even smarter.
The next generation of the technology is an automated system that removes the operator completely, that this boom will extend and coupling occur and refueling happen with just the press of a button. This technology will use image processing algorithms to observe what's happening and react instantly to accommodate, adjust, and make that coupling happen as fast as possible, refuel as quickly as it can, and disengage and carry on.
The updated SMART MRTT will once again revolutionize air-to-air refueling and cement this Dragon's place as one of the greatest machines in the sky. While the A330 MRTT is fast and fierce, another flying monster is more of a gentle giant. One might think of floating airships as a thing of the past, but engineers of this one are looking to the future. Part airplane, part airship, Airlander 10 hopes to bring Zeppelin technology to the modern age.
The combination of technology utilized on the Airlander 10 allow it to have a carbon footprint that is 75% lower than an aircraft of comparable capability.
The Airlander 10 is a really interesting aircraft. It's very long. This makes it the longest aircraft in the world. But ironically, it's also one of the lightest.
Still in prototype phase, this massive craft has been dubbed the Flying Bum, for obvious reasons. It weighs just under 20,000 kilograms, making it only a third the weight of a typical passenger plane.
That's really important because the Airlander uses gas to lift off the ground. If it was heavier, it wouldn't be able to float. To achieve the lightweight in order for the gas to make the aircraft buoyant,
the first flight these crafts saw was in 1900. Their presence in the skies would not be long-lived. In 1937, the famous Hindenburg Zeppelin burst into flames, killing 36 people and earning a bad reputation for this vehicle. By the end of World War II, Zeppelins ceased being produced in any meaningful way. When designers began thinking of the Airlander, an important design tweak was called for right off the bat.
historically we used hydrogen. Hydrogen is a combustible and explosive gas and led to a lot of disasters in the past, like the Hindenburg. The Airlander 10 uses helium as the buoyant gas.
While hydrogen is the lightest gas we know of, helium ranks number 2.
We all know it from the birthday balloons and it makes our voices high, but if we put enough of it into a lighter-than-air aircraft, it provides the same buoyancy that we see with those birthday balloons and allows the aircraft to lift off the ground. Using helium means that we don't get quite as much lift, but the nice thing about helium is it's non-combustible.
The idea behind the Airlander 10 is that 60% of its lift comes from helium, and the other 40% comes from its form, its shape, the aerodynamics, the ability of air to flow over it and generate lift, similar to a plane.
Similar to the Hindenburg, this Zeppelin, while gigantic, is not exactly a speed demon. But that's the point.
It's really not fast. It moves at about 80 kilometers per hour. This is actually the advantage of the Airlander. It gives the ability for passengers to take time and enjoy the scenery as they pass over it.
Its colossal advantage is that it can stay in the air over a certain area for long periods of time. The Airlander hopes to one day accommodate 90 passengers. It will fly at altitudes of 6 kilometers or more and a top speed of 130 kilometers per hour, all while offering a comfortable, quiet ride.
Very unique capability of the Airlander 10 is the ability to stay aloft for 5 days. Very few vehicles can actually do that. But that capability also allows it to do some very, very unique things. So you can actually utilize it for logistics. You could utilize it for coastal or maritime patrol, somewhere where you need to stay aloft for a long time. Surveillance, and as well, as unique as it might sound, is you could use it for VIP transport. You know, take for instance, you have the river cruise. You're not in a rush. You want to see something. Only now you can actually see it from air, and you get the chance to look at everything. So there are some really, really unique applications that this vehicle could open up.
This sleepy Dragon offers various configurations, but at its largest, it could have a payload of up to 10 tons. So how does this simple-looking creature pull off such feats? The magic combo is in its design. The Airlander combines technologies from airships, fixed-wing aircraft, and helicopters.
It uses that aerodynamic lift from the airfoil shape of the aircraft and the buoyancy provided by the helium gas inside it. It's very wide, it's very deep, has a huge internal volume filled with helium gas. The Airlander 10, because it's very, very large and is filled with a light gas, helium, weighs less than the air it displaces, and so it floats. It's buoyancy, just like in water. But in addition to the buoyancy, it also derives lift when it moves forward by the action of the engines and the propellers, and that helps the aircraft take off and fly through the air. It's a pretty remarkable effort.
Engineers chose a lightweight gas, but they still have massive weight issues. Not only did this behemoth need structure, it also needed a huge amount of skin. But structural material necessarily means mass. The Airlander's hull is an elliptical cross-section with a slightly arched longitudinal shape.
It uses carbon fiber composites and fiberglass composites to reduce its weight.
And it is made of these advanced materials as opposed to more conventional steel or aluminum or other metallic materials, so that it can stay up in the air for a longer period of time and stay in flight.
Staying in flight requires that massive balloon not burst. It needs an incredibly tough skin, and one that won't let any of that gas out. How can so much skin not weigh this thing down?
The coolest part of the Airlander 10 is definitely the layered hull structure. The sandwich structure, or the layered structure that's best thought of as a sandwich, has 3 distinct layers. So the innermost layer is one of the most critical, as it's the gas barrier. So it's actually what keeps the helium inside. That layer is comprised of PET, or mylar, and polyurethane. And so the PET is known as polyethylene terephthalate, and you might recognize it from disposable water bottles. So that allows it to keep the gas in. And there's polyurethane as part of this layer, since it allows sheets of mylar to be heat sealed together to form the massive hull structure.
The middle layer is made of an advanced superfiber called Vectran.
Vectran is a liquid crystal polymer, and one of the precursor ingredients for Vectran is benzoic acid, which is a fairly common food preservative. So you might recognize it from pickles or sodas or other items that require preservation. Vectran has high strength, flexibility, and it's resistant to cutting and rubbing. And pound for pound, it's 5 times stronger than steel and over 10 times stronger than aluminum.
And it uses yet another well-known super material.
The Airlander 10 is equipped with Kevlar. So that Kevlar, which is also seen in other types of equipment, like bulletproof vests, provides protection to those critical areas. The outside layer of the Airlander 10's hull is made of Tedlar, which is also known as PVF. And that material is tough, it's light, and it provides protection to the outside of the Airlander 10 from UV rays and other types of weathering.
Its special hull structure enables some special aerodynamics.
Inside the hull of this craft, there are several chambers that have either helium or air in them. The helium chambers are constant, and as we change altitude, that helium might expand or compress, different temperatures as well. And so we need to make that up with a modulated air system where we can control the amount of air in or the amount of air we let out to supplement that air pressure so that we can get lift, more lift, or we can descend.
But while this technology keeps it up in the air, the real mystery designers had to solve with its aerodynamics is how this massive helium balloon could fly. The prototype Airlander reportedly had 4 Thielert Centurion V8 diesel engines. And each of these is 325 horsepower. One has to wonder how the Airlander's engines could support such a massive machine, with yet one more secret ingredient.
Each engine on the Airlander 10 is attached to the hull of the vehicle, and the engines drive a 3-bladed ducted fan. So it's like a 3-bladed propeller within a duct.
The addition of these ducts, these foils around the propellers, increases their efficiency because it prevents eddies from being produced at the ends of the propeller blades.
By contrast, when a conventional propeller spins, air moves from the center out towards the tips of the blade, creating a vortex or a spinning pocket of air. That spinning vortex is a waste of energy. A duct around the propeller stops the vortex from escaping out into the air and redirects the energy back into the fan, creating more thrust. So, a ducted propeller can be much smaller and lighter and still create the same thrust of something larger.
The two engines at the back, being fixed, provide the thrust to drive the Airlander 10 forward. So this is basically what moves you from point A to point B. The two engines at the front of the aircraft can be pitched at various angles. The front engines being able to vector their thrust means that they can cause the aircraft to pitch up, pitch down, and hover. That's really an important feature of the Airlander 10, is its ability to maneuver in small spaces relative to its size and to remain almost motionless for long periods of time. The thrust vectoring of the Airlander 10's front engines allows it to be extremely maneuverable on takeoff. Basically, instead of having to run straight down a fixed runway, the Airlander 10 can lift slightly off the ground, pitch into the direction of the prevailing winds, and move forward and lift up.
The future looks bright for the Airlander 10. It's being designed to achieve a maximum range of 7,400 kilometers. And also being designed are electric engines, which will lessen its environmental impact even more, aiming to be a zero-emissions aircraft by 2030. Although the Airlander draws on helicopter propeller technology and can stay over one area for a sustained period, in other ways, the two crafts could not be less similar. Rather than being slow-moving and quiet, choppers are notoriously noisy and all about getting in and out quickly. The CH-53K King Stallion is the largest and heaviest helicopter in the US military, and one of the most powerful ever designed. With a maximum operating weight of 40 tons, it takes the term heavy lifter to a whole new level.
Helicopters are really amazing, versatile pieces of equipment for getting really heavy objects into locations that nothing else can get things into. So if you want to drop 53,000 pounds on the top of a mountain or on the top of an office building, this is the vehicle that you want, the King Stallion.
While most of us take helicopters for granted, seeing them in action reminds us of how bizarre they are. Considered rotorcrafts, rather than planes, helicopters set themselves apart by being able to take off and land vertically. They can also hover, fly backwards, and fly sideways, enabling them to maintain extremely difficult positioning. Like bumblebees, they're somewhat of an aerodynamic riddle that we greatly depend on. A chopper's main advantage is in accessing challenging geography, including very tight spaces and places with no runways.
It may be a relief mission to help people in distress who have had a tornado or a flood or a fire. It may be a search and rescue mission to help a boat that's in distress or people that are in trouble on a mountain in a forest fire situation. If you're one of the people in trouble at the time, it sure would feel nice to see that big CH-53K come over the horizon and pick you out of the water after your boat sinks.
And military helicopters are also used to transport troops in cargo. Today's conflict zones are often in difficult, isolated areas that are hard to get supplies to. And making a helicopter large enough to fit a military's cargo requires some design wizardry. The King Stallion was first used by the Marine Corps in 2015.
The King Stallion's claim to fame is its ability to lift not only with the hook, but it has a huge internal cargo capacity. It's used to move troops from either seaside or shipside locations to remote locations in mountains or in the field. You can put troops in this as well as many, many thousand pounds of equipment and move it to a remote location very quickly.
The CH-53K King Stallion is the king of helicopters for the U.S. Navy. It is their biggest transport helicopter for amphibious operations.
The King Stallion replaced the Super Stallion before it. And while the footprints of both helicopters are similar, the King's cabin is an extra foot wider, allowing it to better handle cargo and vehicles.
The Super Stallion can carry a Humvee. It can carry it on a sling, but the CH-53 King Stallion can also carry it internally. So the cargo hold is big enough to hold a Humvee. The CH-53 King Stallion can do 3 times what the Super Stallion had done. So pretty big increase in capability.
But what makes it truly extraordinary is its ability to carry that payload much higher in altitude than its predecessor, and in much hotter temperatures. This lets the King succeed in the military's most demanding flight environments. As with the Bumblebee, who needs a lot of power to fly that big body with such little wings, one of the helicopter's biggest obstacles is simply getting enough power. The heavier the chopper, the more power it needs. And how the King Stallion gets enough power for such massive loads is one of its many secret ingredients. The King Stallion is powered by 3 new T408 GE400 engines, each churning out an incredible 7,500 shaft horsepower. By comparison, the Super Stallion's engines only generate 60% of that. The increased power of the King enables it to carry 40 tons at 315 kilometers an hour, letting it move much more deftly in critical situations or hostile environments. But it wasn't just power engineers were concerned with. These helicopters are made to go over sand and ocean. Yet both these substances could be deadly to an engine. So, engineers created sand-tolerant, corrosion-resistant compressors and turbines, replete with high-tech cooling schemes. And crucially, they managed to pull off all these innovations, while at the same time coming up with an engine design that has 63% fewer parts than its predecessor.
Engines of the King Stallion have a modular design. When we build engines in a modular nature, it allows us to reduce the number of parts, making them more reliable and easier to maintain.
But no matter how impressive the King's new engines are, a helicopter isn't a helicopter without its rotors. And the rotors on this machine are perhaps the best magic of all. The main rotor is about 24 meters across, about twice the length of a standard telephone pole, and contains 7 massive blades.
The blades of the King Stallion are a lightweight composite structure. The core of that structure is what's known as a honeycomb. And like a true honeycomb, that structure is mostly air, allowing the blades to stay strong but light. The outside of the blades, or wrapping around the honeycomb, is a layer of glass fiber and epoxy, protecting the honeycomb from the outside elements. Because they're lightweight composites, those blades can be made even bigger, allowing the helicopter to have more lift and carry more weight.
The heavier a helicopter is, the greater the load on the rotor blades. So consider if you have a high weight, if you have 2 blades, or if you put on 4, then the more you can lift. So the more blades, the greater the lift. Additionally, the more blades, the bigger the airfoil surface that is generating the lift.
To further help with that lift, the blades also have droop tips.
Generally, as you move something through the air, there is drag that can be generated. The geometry that's slicing through the air could create small vortexes and different points of pressure and suction. And so the geometry of these blades really controls how much drag this craft is going to experience. The droop tip minimizes that drag.
As an added bonus, this allows the King Stallion to fly more quietly than any other craft in its class. And it has yet one more magic grip up its sleeve with its rotor.
One of the really neat tricks about this machine is that, say it lands on the deck of an aircraft carrier. That takes up a ton of space. These rotors are really, really big, but within 2 minutes, it can actually fold its rotors in half and change its own footprint. Your colossal machine basically gets a little less colossal.
That this rotor can be so powerful, yet also so light and adaptable, gives the King its edge. But even its tail rotor is fit for a king.
The CH-53K's tail rotor is very impressive. It generates just as much thrust in the tail rotor as what a Sikorsky S-76 executive helicopter does for its main rotor. And that helicopter is about a 5,000 kilogram maximum takeoff gross weight.
One of the crucial things with the tail rotor that engineers had to figure out was how to prevent the chopper from spinning around once it lifted off the ground. This relates to Newton's third law of motion. For every action or force in nature, there is an equal and opposite reaction. So as the engine drives the main rotor in one direction, the fuselage wants to rotate in the opposite direction. Their solution is part of this craft's superpower. Its tail rotor's anti-torque system, thrust is created to push the tail boom in the opposite direction to which it wants to turn. When the thrust from the anti-torque system in the tail matches the torque being created by the main rotor, the helicopter will remain pointing forward when it lifts off the ground. The challenge is, the more powerful a helicopter's engine, the more thrust it needs to be produced by the tail rotor. And the best way to get more thrust is more blades. For example, the Bell UH-1 Iroquois, one of the most common military helicopters ever built, was given 2 rotor blades for the job. The King Stallion has 4, and like everything else about this craft, its 4-bladed tail rotor is huge at 6 meters in diameter. It alone creates more thrust than the main rotor on most choppers. Not only is the King Stallion the heaviest lifter around, it's brainy too.
Like most modern aircraft, the King Stallion has a glass cockpit. Now that doesn't refer to the structure or what the thing is made out of. It refers to the fact that on the instrument panel, instead of old-fashioned round gauges with a needle inside like a little clock and a glass face, it's basically got several computer screens, almost like iPads, on the instrument panel, and pictures of the round gauges are displayed on those screens. And that's very, very useful. It means they're easy to program, they react very fast, they're more reliable than the mechanical gauges, and they're lighter.
The King's cockpit has a night vision system, and it even has an upgrade that can see the journey through a blinding sandstorm.
The King Stallion's fly-by-wire system allows the computer system to take over some of the actions of the pilot.
What's very unique about fly-by-wire, before you actually had mechanical linkage to all of the systems throughout the aircraft, whereas with fly-by-wire, what you've done is you've got augmentation. The pilot actually inputs what they want to do, and then the fly-by-wire actually compensates it so the pilot achieves what they want to do, and they don't have to do continuous inputs and correction.
This reduces the pilot's workload and allows the computer to maintain the aircraft's stability.
The active controls provide tactile cueing, similar to how your video game controller at home vibrates to tell you you're driving off course.
It can navigate accurately in all weathers.
Fly-by-wire as well is handy because it can reduce the weight versus a mechanical system. The other thing too is you could actually distribute it throughout the vehicle, and it actually makes it more survivable as well, so that if you got hit, you don't take out a critical system.
The CH-53K King Stallion is the largest helicopter of any Western Air Force at the present time.
And it's about to push its limitations even higher. It can now take part in air-to-air refueling and withstand the massive turbulence produced in the tanker's wake.
The King Stallion's strength and power allow it to stay in formation behind refueling aircraft and allow its fuel probe to hook up with the hose drogue from the refueling aircraft. So think of this. We actually have a helicopter flying behind an aircraft and capturing the hose drogue. Being able to refuel in air dramatically increases the range of operation of helicopters like the CH-53K and to extend their capability and action of radius.
It appears there's no end for this colossal copter. And as we look to the skies and behold all of our massive-made dragons, it also appears there's no end to our desire and ingenuity when it comes to making bigger, better, faster, colossal machines.